Hi, I'm Andrew from KX Systems. Today I'm going to give you a quick introduction to the KDB Plus database. KDB Plus is a time series database from KX Systems known around the world for its performance, scalability, and its elegance. Today I'm going to focus on all three, but in particular I'd like to point out the elegance. The elegance comes from the Q language from KX. Q is an array programming language based on APL. Q is used in KDB for general purpose programming, so think Python, for vectorized operations, think NumPy, and for the manipulation and querying of tabular data, so think of the pandas library. So to start us off, I'm going to do some basic linear algebra. As you can see here, Q enables us to define vectors and to perform vector addition, vector manipulation, scalar multiplication, all of the things you'd expect from a vectorized operation library. In order to visualize the tabular operations, let's bring in some real data. I'm going to bring in some TAC data, or trade and quote data. This is data from a live financial market. The data consists of quotes, which is the bids and offers that are available in the market at any time on a selection of different stocks, and trades, which are the buys and sells of those quotes. So as we can see, we have about 2 million quotes and about 500,000 trades. So not a bad amount of data to run some experiments on. The first query I'm going to try, I'm actually going to run in Python. What I want to do here is aggregate the data in a series of different ways in a single query. In Python and in pandas, as you can see, this takes up quite a lot of code. Here we have 3 lines in order to generate the aggregation that I just described. Runs fine, but now let's look at the same code in Q. Much simpler, much less code, and much more elegant and informative. It reads as I described it to you a moment ago. What we're seeing here is the query almost as pseudocode, and this extends to more complicated queries. In the next query, I'm getting the spread, which is the difference between the ask and the bid price at any time, aggregated both by the symbol and into 30-minute buckets for each symbol. As you can see, this is one line for Q. For pandas, this could take an entire page. Also in Q, we have the sorts of joins that you'd expect from any tabular data manipulating language. Here, for example, I'll demonstrate a simple left join of reference data. Where Q really comes into its own, though, is with its time series joins. What you can see here is what we call an as-of join. I'm joining quotes and trades, not by an exact match, but by a temporal join. What I'm doing is, for each trade, I'm getting the prevailing quote at that time and joining it to the table. This sort of query is particularly important when you have stochastically arriving data, like financial market data, and allows you to investigate concepts like, for each trade, was it or was it not within the prevailing bid and ask at the time? Everything I've done so far has been in memory. It's been running in the memory of my computer. But if I want to extend to much larger data sets, we have to persist the data. We have to deal with on-disk databases. KDB Plus is a hybrid on-disk and in-memory database. So we get the best of both worlds without needing to change the language. We use Q for both. Let's take a look at some on-disk data. On disk, we have the same basic data. Again, we're looking at trades and quotes. Only this time we can deal with much bigger data sets. This time, as you can see, we have 200 million quotes and about 50 million trades. The schema is exactly the same. We're looking at the same data. The only difference is, in both the quote data and the trade data, we have this additional column which gives us the date that the time series data occurred within. So, for example, a basic query we might want to run is to find out how many trades we had on every single date. And that's quite straightforward in Q. We can again, using exactly the same language as before, run more complicated queries. Here I'm going to run a query that gets the volume weighted average price again and the total volume again. But this time I'm also going to get the high, low, open and close price for each day and for each symbol. A very complicated query on a massive amount of data, but as you can see, KDB gets the results back very quickly and with minimal amounts of code. I'll also repeat the point that the code reads as I described the problem to you. From this data, I can extract the average price for each sim for each day, giving me a time series for each symbol. And I'm going to use this data to demonstrate the expressiveness and mathematical consistency of the Q language. To start off with, I'll pull out the prices for Apple as a time series. And I'll find out what's the correlation of Apple with Microsoft stock. The nice thing that KDB allows us to do is with very little modification to that query, I can now ask the question, how does Apple stock correlate with every other stock in my data? And finally, with the code actually getting shorter, not longer, I can ask the question, how does every stock in my data correlate with every other stock? Next, I want to look at the real-time capabilities of KDB+. Everything we've looked at so far has been static, but of course, financial markets don't stand still. Data arrives through the day, and we need to be able to query it as it arrives. KDB+ allows us to do this. Here I can subscribe to a stream of data, and we can see that instead of having a static table size, the data is increasing over time. And as it's increasing, we can continue to query the data as we did before. Here, for example, I can get the number of quotes for each symbol, and we can see that the number keeps increasing over time, as we would expect. However, that's not the best way to query real-time data. KDB provides a further capability that we call streaming analytics that allows us to act on the data as it arrives in real time. And that's great, but it's not always the best way to deal with real-time arriving data. One problem, for example, is that every time we aggregate the data, we have to aggregate the entire table again. That means repeated work. A better idea might be to act on the data as it arrives, directly. KDB+ provides exactly this functionality in what we call streaming analytics. Streaming analytics allow us to define functions which will act on data as it arrives. This allows us to aggregate the data, but of course it also allows us to provide warnings based on the data and possibly even to take action on the data. Here, I'll register a query to act on the quotes as they arrive. And as before, I'll get the total number of quotes for each symbol. But when I run it as a streaming query, you can see that it keeps me up to date in real time, and we don't have to query the entire table every time. This can extend to more complicated queries. So again, if I can keep track of the total volume and the total value of each trade per symbol, I can maintain a real-time volume-weighted average price for the trades. This is much more efficient than real-time queries. These are streaming queries. So finally, I'd like to talk about KDB Plus's integration with Python, which we manage here via the embed py library. If I pull some time series data out of the historical database that we've been concentrating on, I can get a time series of prices, this time split up by date and in 15-minute time buckets. I'm going to use matplotlib to visualize the time series for the Dell stock. As you can see, the code is again elegant because I'm using KDB Plus as a wrapper, but the underlying library is the matplotlib pyplot library. And again, I can extend very elegantly using KDB Plus to now show time series for all of the stocks that I've been looking for, again, with a single line defining the plot. So that concludes our tour of KDB Plus. Hopefully you've learned something about the elegance, performance, and scalability of KDB Plus and the Q language. Thanks for listening, and feel free to check us out at kx.com. Thank you.